President of North Fork Audubon Society, and welcome and thank you all for coming. On behalf of North Fork Audubon, we'd like to thank the Suffolk County Department of Economic Development and Planning for their grant which supported this event. We couldn't have done it without them. So we hope you'll use the notebooks that we provided to jot down any useful information you hear today. And please also peruse that flyer that we put in there listing our ongoing projects, which include the gardens and trails at our headquarters, which, if you don't know, is Inlet Pond Park, right here in Greenport, or right there in Greenport. As well, there's also ways that you can get involved as a volunteer, and you can just attend our educational programs and bird walks, so check out our website. So our speaker today, Doug Tallamy, is the T.A. Baker Professor of Agriculture in the Department of Entomology and Wildlife Ecology at the University of Delaware, where he has authored 106 research publications and has taught insect-related courses for 41 years. 45, sorry. 45. Chief among his research goals is to better understand the many ways that insects interact with plants and how such interactions determine the diversity of animal communities. He's written several books, some of which are on the back table, on Bringing Nature Home, The Living Landscape, Nature's Best Hope, which was a New York Times bestseller, The Nature of Oaks, and then his latest book, which just came out, How Can I Help? Saving Nature in Your Yard, published just last month. And you may have seen he was in the New York Times a few weeks ago, and he was on NPR, just yesterday or the day before. His awards include recognition from the Garden Writers Association, Audubon, the National Wildlife Federation, Western Carolina University, the Garden Club of America, and the American Horticultural Association. Doug lives with his wife Cindy, who couldn't come today, on their restored property in Oxford, Pennsylvania. So at North Fork Audubon, our mission is to connect people with nature. And that is why we are so looking forward to Dr. Tallamy's message of home-centered ecology and biodiversity, the success of which depends on all of us in the community working together. We are confident that Dr. Tallamy's philosophy of homegrown national parks is perfectly aligned with our mission and will give us hope for the future, which we need.
Well, Peggy has summed it up pretty well. Any questions? You know, when you set up a talk, it starts months earlier. And I think the first time we talked about this talk was last October. They said, we want you to talk about landscaping for birds. I said, okay, well, I've got a talk. It's called Chickadee's Guide to Gardening. It talks about landscaping for birds. And a couple months later, I got another email and said, why don't you talk about Homegrown National Park? I said, okay, I've got to talk about Homegrown National Park. So we'll do that. And then not long ago, they said, we really want you to talk about pollinators. So I've got to talk about restoring the little things that run the world, and that includes a lot of pollinators. The common theme to all of these, though, is insects. A lot of people don't want to talk about insects, but if you don't have insects, you don't have plants. If you don't have plants, you don't have birds. If you don't have plants, you don't have nature. So you don't have any of those things without insects. So they really are the core to my message, no matter what talk we're talking about. And of course, it was E.O. Wilson, Edward O. Wilson, at Harvard, not Cornell, the late Edward O. Wilson, who told us insects are the little things that run the world. And he did it way back in 1987 with this paper. And his message was very, very simple. He said, life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if that happened, the energy flow through our terrestrial ecosystems would be so totally disrupted that the food webs that support our vertebrate animals would collapse. We would lose our amphibians, our reptiles, our birds, and our mammals. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. The important part of this message is that there wouldn't be any humans either. We would not be able to survive a world without insects. So it was a somber message, but it was largely ignored because nobody was worried about losing insects. As a matter of fact, we spent most of our time thinking about how we could kill insects, and we got very, very good at that. As a matter of fact, we used to have National Insect Killing Week. Now, this was 1929. But it was a campaign to boost the sales of all brands of chemicals to rid the community of insects. Notice, not rid the community of pests, insects. They all got to go. We don't have National Insect Killing Week anymore, except the culture has not changed. Most people see an insect, it's bad, we kill it. And we don't even think about what it might do. Now, even if we were successful in killing all the insects in agriculture, and you can make an argument for that, or killing all the insects at home, we still don't worry about losing insects because we have thought that there's still plenty of insects in our natural areas. Well, there's a couple of reasons why that's no longer true, and one of them is we don't have very many natural areas anymore. We've turned them into our cities. They're not designed to support insects. We've turned them into our suburbs. They're not designed to support anything. Even our rural areas are not designed to support insects. And of course, we've got agriculture. Rangeland alone, 770 million acres of rangeland in the US. That's 4.5 times the size of Texas, dedicated to cattle. It's not designed to support insects. And most of it is overgrazed, so very poor insect habitat. As a matter of fact, food production now claims more than half of the terrestrial surface of the earth. And of course, none of that space is designed to support insects. Another reason our natural areas are not supporting the insects that we need is that they are invaded with invasive species. And you folks know that. We know that all up and down the east. As a matter of fact, there's very few places in the US you can go where you don't have a number of invasive species. We'll just talk about plants that have changed the nature of our natural areas. Why is that? Well, non-native plants, whether they're invasive or not, are very poor at supporting insect populations. So you have food web collapse when they displace the species that do support our insects. And our natural areas have been invaded by 3,300 species of plants from other continents. Big problem. And we've, of course, been measuring this in my lab at the University of Delaware. A number of different ways, a number of different times. But we can now tell you what happens, at least to caterpillars, when you allow non-native plants to displace native plants. This is one simple experiment that shows it very well. Went into hedgerows in Maryland, Pennsylvania, and Delaware that were invaded with non-native plants like autumn olive and oriental bittersweet and Japanese honeysuckle and bush honeysuckle and all the things that you have around here as well. Measured caterpillar populations in a standardized way in those invaded habitats and compared them to hedgerows that were not invaded. And the real challenge here was finding hedgerows that were not invaded. And we found a 68% reduction in the number of species of caterpillars in the invaded hedgerows, a 91% reduction in the abundance of those caterpillars, and a 96% reduction in the biomass of those caterpillars. The amount of energy that those caterpillars are adding to those hedgerows. And if you think of caterpillars as bird food, you have just reduced bird food by 96%. And it's not just invasive plants that are causing problems. Our typical ornamental plants, whether they are invasive or not, have changed the nature of the food web wherever we design landscapes. So let's say the only tree in your yard is a ginkgo. It doesn't support any caterpillars. And about 83% of our ornamental plants are non-native. So we have 135 million acres of residential landscapes out there. It's a huge hit on the food webs that support our birds and everything else. Now, when I was young, sites like this were, I could still remember looking up at streetlights right across from my house. This was in Plainfield, New Jersey. It was a city. But you could still see insects zooming around the lights all night long. When you drove, particularly out in the rural areas, that's what your headlight looked like. Now you look up at a streetlight, you don't see anything. And your windshield's pretty clean too. So we're winning our war against insects, and that's why we're seeing headlines that are starting to recognize this, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Well, E.O. Wilson told us what it would mean if we actually lost our insects. It was troubles with honeybees that got us to start measuring what was happening to our insects, starting with not just the honeybee, but our native bees as well. And of course, they're declining for the same reasons as the honeybee is in trouble. We have 50% of our Midwest native bees that have already disappeared from their historic range just in the last century. There are 4 species of bumblebees that have declined 96% in the last 20 years. Now, they're not extinct, but they're functionally extinct. They're no longer common enough to be performing their roles in their environment. 3 species of bumblebees may already be extinct. I think you have to disappear for I don't know how many decades before they say you're really extinct. 25% of our bumblebee species are at risk of extinction. Not good news there. This paper just came out a couple of weeks ago. Rapid butterfly declines across the US, 22% decline in our butterflies just since the year 2000. Now, Europe has done a better job of measuring insect declines. 30% of Europe's orthopterans, the grasshoppers and the katydids and the crickets, are facing extinction. Big study out of Germany really kicked this off. 79% decline in flying insects since 1989. 46 species of moths and butterflies have already disappeared from Germany. And as of 2014, this is measured by Durzo, we had a 45% global decline in insects, and the latest statistic I saw is somewhere around 75%. The little things that keep us alive on this planet have declined 75%. This is not good. How many people even know this? We've got to do something about it. And of course, here's the connection. As insects decline, so did the birds that depend on them. And when do they depend on them? When they're reproducing. If you don't reproduce, it doesn't take long to have no birds. So 432 species of North American birds are now threatened with extinction according to the State of the Birds report. And it's not because there's only 4 or 5 left of each one. It's because of the trajectory of their declines. The rate of their decline is so rapid. That's now the signal of impending extinction. 3 billion fewer breeding birds today than just 50 years ago. So it is impacting our birds. We went to, that was a study by Rosenberg et al. We went to that study and we looked at the terrestrial bird species and divided them up into 2 groups. The species that require insects, particularly when they're reproducing, and the species that do not require insects. So things like finches and doves and crossbills can actually reproduce without insects. They can make a little milk out of seeds. And those species didn't decline at all in the last 50 years. But the species that depend on insects decline, on average, 10 million individuals per species. It doesn't prove cause and effect, but it does suggest as you take bird food away, you lose the birds. This is an amazing statistic. The English sparrow and the starling, invasive birds all over the world, are now red listed in England because Great Britain has sterilized its landscapes so much that even these invasive birds can't find enough to eat. And it's one of the reasons that the UN is predicting we will lose 1 million species to extinction in the next 20 years, and they made that prediction 3 years ago. Most of the species will be insects, but that reverberates up the food web. It's a prediction, hasn't happened yet, and it is our job to make sure it does not happen. Because again, those are the species that keep us alive on this planet. It is not Walmart that keeps us alive. So does it matter? Of course it matters. The creatures that keep us alive are disappearing. Now, if I said to you, introduced plants are reducing your bank account by 96%, I probably wouldn't have to say it too many times for you to get the message. This is important. But it's insects that are the currency in our ecological bank account. And we depend on our ecological bank account. That is the nature that keeps us alive on this planet. We're totally dependent on it. So I think our only viable option is to find a way to live in harmony with the natural systems that support us. In harmony, live sustainably. And sustainably doesn't mean for the next 5 years. It means forever. And that world has got to include insects. So how are we going to do that? Let's start with where we're going to do it. We're going to do it on private property because most of the country is privately owned. 85.6% east of the Mississippi is privately owned. 78% of the entire country is privately owned. So if we don't practice conservation on private property, we're going to fail. And remember, failure is not an option. It's not an option. So we're talking about having viable ecosystems on a landscape like this. And I took this from a helicopter, not far from where I live. This, of course, is the current status symbol. It's a beautiful landscape that is completely dead. How are we going to start saving insects at a home like that? Well, let's think about what the causes of insect decline are. There's a number of them. Dave Wagner at the University of Connecticut says it's death by 1,000 cuts because there's so many different causes. But the major ones are misuse and overuse of pesticides. Habitat loss, of course, is huge. Every time you build a road, every time you build a house, there are no more insects there anymore. That's habitat loss, and we continue to do that every day. Plant choice. The plant choices that we put on our properties are determining the base of the food web, whether or not we're going to have viable food webs or not. Many of those plant choices have caused the invasive species problem that we have. What I say, 83%, 85% of our invasive woody plants are escapees from our gardens. Light pollution, major cause of insect decline. Climate change, major cause right now. But I actually see this as good news because these 5 causes are easily addressed by individuals at home. I am not going to make an assignment that you have to solve climate change yourself. We need to do things to solve climate change, but that's you got to bump that up a little bit. Those are policy changes. But these things we can address right at home. But before we do that, we have to decide what insects are we going to try to save? What are we going to favor here? There are a lot of insects out there, or at least there used to be species, 3 to 4 million species of insects. The reason I say 3 to 4 is most of them are undescribed. We don't know how many species are out there. 164,000 described species in the US, but again, I can find an undescribed species in my yard almost any day that I look for them. It's not hard to do that. But that's a lot of species. We're not going to have all of those in our yard. So which ones should we favor? Well, there's 2 groups I think we need to focus on. One would be the insects that maintain plant diversity. Plants, of course, are the base of the food web. They're capturing energy from the sun and through photosynthesis turning it into simple sugars and carbohydrates, which is the food that keeps just about all the animals on the planet alive. But you've got to have those plants to do that, which means you've got to have the insects that maintain those plants. The other group is we have to have insects that take the energy from that food, from the plants, the food that those plants are making, and distribute it up the food web. It's insects that actually do that. So what are we talking about? We're talking about pollinators, of course. They're the ones that are keeping our plant diversity up there. But who's transferring the energy? It's caterpillars. We're going to talk about both of those groups, starting with pollinators. Does anybody recognize that plant, that flower? It's very common. No? That's Virginia creeper. It's a tiny little flower. You don't even know it is in bloom, but it is a magnet for native bees. They love it. So let's talk about why we need pollinators. Now, if I were to ask you why we need pollinators, the answer I typically get is what the media says. We need pollinators because they pollinate 1/3 of our crops. It's actually about 1/12 of our crops that are pollinated by animals. And I hear people say, well, I don't live next to a farm, so I don't need any pollinators. Forget the crop argument. We need pollinators everywhere because they're pollinating 80% of all plants, including some of our crops, and 90% of all flowering plants. If we lost our pollinators, we would lose 80 to 90% of the plants on the planet. That is not an option. So we need pollinators, we need them everywhere, we need plants. We're not talking about good land stewardship here. We're talking about essential land stewardship. We will not persist on this planet if we lose our pollinators. That bumps them up on the priority list. What is a pollinator? A lot of people think every insect that goes to a flower is a pollinator. No, it's a flower visitor. There are lots of insects that go to flowers that do not move pollen from the male part of the flower to the female parts of the flower, which means they're not actually pollinating. They are eating pollen or they're drinking the nectar, but they're not actually pollinating. So the best pollinators are these. We have one species of honeybee introduced, of course, mostly for our European crops that we brought over. It's a very good generalist pollinator. We've got between 3,600 and 4,000 species of native bees that did just about all the pollination on the planet before we brought the honeybee over. And we've got around 14,000 species of moths and butterflies just in North America. Now, butterflies actually are terrible pollinators. They're pretty, and we want to save the monarch because it's pretty and it has a nice migration, but it's not because it's pollinating. But the moths, many of those moths are actually pretty good pollinators, sphinx moths and some other groups, and they do most of their pollination at night when nobody's looking. So a lot of good pollination happening there with the moths. Now we have to know what a bee is. I talk about saving pollinators at home. We want to make landscapes that our native bees are going to thrive in. And people say, well, I'm not going to do that because I don't want to get stung. I say, well, no, the native bees are not going to sting you. Most of them are asocial. They're not protecting a hive. And they say, well, you're wrong. I got stung last week. And I believe that. But you didn't get stung by a native bee. You got stung by a yellow jacket. That's actually a wasp. It's a predator. It's not a good pollinator. And they are aggressive. And I'm not saying we need a lot of yellow jackets and bald-faced hornets and Polistes wasps at home. What we do need are the native bees, the ones with the fuzzy abdomens, that they're not predators, they're herbivores. They eat pollen and nectar, and that's the 36 to 4,000 species that are pollinating so many of our important native plants. So how do we make landscapes that are favorable to these native bees? Well, we have to give them something to eat and a place to live. It's pretty simple. Where do native bees nest? 3 main places: in the ground, woody stem nesters, and pithy stem nesters. Now, most of our native bees are ground nesters. 70% of them nest in the ground, which means they dig a tunnel in the ground, sink a single shaft, and then make side shafts off that tunnel, pack them full of pollen, close up the front of the tunnel here, and that's it. So this is a Calides bee. You commonly see them in the spring before the vegetation covers much of the ground. But this is one of the species of native bees that are nesting in the ground. So if you have a piece of property that includes ground, you can support native bees, and most of you do have ground. They prefer a slight south-facing slope. The soil around here is great. It's perfect. It's kind of a sandy loam thing. They're really easy to dig in. But even if you have clay soil, there are native bees that will go right through clay as well. Pithy and woody stem nesters will hollow out the center of the stem, and then they make cells sequentially. So this is the oldest cell here. They pack it full of pollen, lay an egg on it. Here's the bee larva. This is a picture from Heather Home. Then they block off that cell, make another cell, pack it full of pollen. This guy's a little bit younger, so he's smaller. This one's younger yet, so he's smaller. And when they mature, they pupate in these cells, and then they tunnel out sideways through the stem and leave a hole there. Both pithy stem and woody stem nesters do that. By pithy stems, I'm talking about the stems of our meadow plants that were up last year. It's goldenrod, it's evening primrose, it's ironweed, wingstem, echinacea, the things that we commonly have in our garden. But what do we do in the fall? We cut them down at the base and get rid of them because they're not so pretty. But it is those stems that many of our native bees are going to nest in the following summer. So you have to keep them there. Now what you can do is cut them down maybe 15 inches off the ground and then take away. But you don't want to do that in the fall either, because the seeds of those stems, particularly goldenrod and asters, are used heavily by our overwintering birds, particularly the sparrows. You might notice sparrows don't go to your bird feeder. They're depending on stuff like this, and if you neaten up in the fall, you've just removed all the bird food for that entire winter. So in the spring, after the seeds are gone, you cut them down about 15 inches off the ground, and then those are the stems that our bees will nest in this coming summer. This is what elderberry looks like, a woody stem, which is soft, so the woody stem nesters like it. After the bees have emerged from their cells, they will nest in the dead stems of elderberry. And you might notice elderberry doesn't live that long and it starts to die back. But what do we do as good gardeners? We trim out those dead stems. So we just removed what those native bees need. In a typical residential landscape, there's very few opportunities for woody stem nesters. So we have invented bee hotels. I use the term "we" loosely, but any hole like that. So these are little pieces of bamboo cut up or drilled holes in wood stock. are opportunities for our woody stem nesters. And the bees do use them, and people love them. Sometimes they go crazy making them. So this is a lot of fun for people, but research is showing you don't want big bee hotels because it concentrates all your bees in one place. It puts all your bees in one basket. If a predator or a disease finds it, it takes out all the bees. So it is much better to have small, not so fun bee hotels scattered throughout your property. You want to put them in something that's out of the rain. So make a little roof for it or something. You don't want rain on it. But then you're not putting all your bees in one basket, and it's much closer to the natural situation that your property used to support. This is an idea that it's a good one. You get a log, and pine is great. When a pine tree dies or is cut down, it actually has a lot of beetle larvae in there, and they will tunnel out when they mature, and they leave a perfect hole for the native bees. So this isn't going to last very many years, but before it totally decays, it's a wonderful site for native bees, and you can stand it up wherever you want to in your garden. Okay, what do bees need to reproduce? They need pollen, and they need nectar, and they need it all season long. This is the distribution of native bee species in New England. Data from Jared Fowler. They come out in March, and there's still a few around in November. It's a sequence of species. Most of the species are out right now, May and June and July. But it means you need forage, you need flowering plants all season long, which is why no mow May makes no mow sense. Because if your lawn is terrible and you actually have plants that bloom in your lawn and you don't mow in May, but then you mow in June, you've pulled the rug out from all those bee species that require forage all season long, not just in May. So it's much better to create pollinator gardens that are never mowed, never walked in, that have a sequence of bloom, and that is the big challenge. How do you get that sequence of bloom, particularly on a small property? Sometimes it's really hard to do that. What species should we have for our native bees? Sam Droege, who, by the way, he works with the Bee Lab, the USDA Bee Lab at Patuxent, Maryland, which was just closed down. Sam Droege, who's Mr. Native Bee of the country, has just been fired. But he says, meet the needs of our bee specialists, because the generalists will use those plants as well. So just like we have a number of caterpillars that can only eat particular plants, we have a number of bees that can only reproduce on the pollen of particular plants. And those are the plants you want to use because, again, if you satisfy the needs of the specialists, you're also satisfying the needs of the generalists that can use those plants too. Why are bees specializing? Because flowers are so different. The relationship between plants and pollinators it's a highly co-evolved one. Plants want bees to take their pollen to another member of their species. They don't want them to take echinacea pollen and fly to ironweed. That's not going to help the echinacea at all. So they develop specialized relationship with particular species of bees. The pollen grains evolved to stick onto the hairs of particular species of bees. They're very efficient at transporting them. And there's all kinds of opportunities for specialization because flowers differ in their timing of appearance, what they look like, what they smell like. The floral and pollen morphology is very different, and they different nutritionally. And bees can specialize on those differences all the time throughout the country. So for example, you won't have Andrena facilii unless you have Phacelia. That is the only pollen that bee can reproduce on. You won't have Andrena asteroides if you don't have native asters. You won't have Andrena origine if you don't have spring beauties. Just about every plant in this country has at least one specialized pollinator on, and some have very many specialized pollinators. Calides albescens needs false indigo. We can go on and on and on. These are the best species in terms of supporting specialist pollinators. Our native sunflowers, our native asters, goldenrods. If you have those three genera alone in your yard, there's between 41 and 44 species of native bees that can reproduce in your yard that can't reproduce in your yard if you don't have those plants. And again, the generalists will follow those, use those plants as well. And then as you go down the list, fewer and fewer are using them. And then again, a whole bunch of plant genera where there's only one specialist bee. So a fall garden like this with goldenrod and blooming asters, not only is it great for the migrating monarch, not only is it essential for the migrating monarch, but it also is wonderful for our specialist bees. How do you find out what the best specialist bees are where you live? You go to Native Plant Finder, National Wildlife Federation Keystone Plants by Ecoregion. That's the website right there. That will tell you what the best plants are in your ecoregion. Now, we admit right away, this is at ecoregion level 1, which is really, really generalized. We're trying to get this up to ecoregion level 2, but things move really slowly at the National Wildlife Federation. But it gives you a good starting point. You know, nobody likes poison ivy except the bees. They did a study in North Carolina where they looked at using DNA. When honeybees go into the hive, you can scrape the pollen off and you can see what species of pollen they were bringing back. They brought back pollen from 18 species of plants, but poison ivy led the way. They brought back more poison ivy pollen than any other plant species. So you might have a war against poison ivy, but if you really want to help the bees, keep it around. All right, that's it. That's all we're going to talk about with pollinators. Let's talk about my favorite subject, which is caterpillars. They are the bread and butter of terrestrial food webs, according to Dan Jansen. And that's because they are transferring more energy from plants to other animals than any other type of plant eater. If you design a landscape without a lot of caterpillars in it, you will have a failed food web and eventually a failed ecosystem. So here we go. Why is this important for birds? Because birds eat a lot of caterpillars. It's not just that they need caterpillars to reproduce, they need thousands of caterpillars to reproduce. Now this is the stat I always throw around, but all the birds do this. But there's a number of birds where somebody sat in front of a whole bunch of nests and counted the caterpillars coming in. 6,000 to 9,000 caterpillars, depending on the number of chicks in the nest, just to get to the chicks to leave the nest, to fledge. And then after they fledge, the parents continue to feed them caterpillars another 21 days. Nobody's counting them because they're flying all around, but you're talking about tens of thousands of caterpillars to make one clutch of a bird that's a third of an ounce. Where are those caterpillars going to come from? They're going to come from the plants in your yard, which means you've got to have plants that make caterpillars. So how do we increase the number of caterpillars in our yards? We add the plants that make those caterpillars, which seems very straightforward. There's a catch, though, and that is that most plants don't make a lot of caterpillars. So we have to be fussy about which ones we choose for our landscapes. This is elderberry, for example. Great pollinator plant, very nice bloom. Great berry maker, wonderful for the birds, particularly in midsummer, but it's terrible at making caterpillars. I only know of 2 species that use elderberry, and they're quite rare. So if you're trying to really support breeding birds, elderberry is not going to do it. Let's talk about why caterpillars are so fussy about what they eat. It's because plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their tissues with nasty tasting chemicals. Secondary metabolic compounds that make those tissues either bitter or downright toxic, which is why we don't run out and start eating black cherry leaves. There is a trace of cyanide in there. You probably don't want to eat it. So plants do defend their tissues, and only the insects that have adaptations against or to get around, to circumvent those defensive chemicals, those are the only ones that can actually eat those plants. How do they do that? They develop specialized enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize their exposure to those compounds. It takes a long period of evolutionary history with those plant lineages for all those adaptations to fall into place, and once they do, the insect is locked into eating that particular plant. And 90% of our insects are host plant specialists. They can only eat particular plants. That is why when we bring in all these plants from other countries, either as ornamentals or as invasive species, most of our insects, particularly caterpillars, cannot eat them. They have not been here long enough for them to develop that specialized relationship. So you end up with very little to eat. There are 3 types of plants out there. Plants that actually contribute energy to local food webs, plants that do not contribute energy to local food webs, and plants that remove energy from local food webs. The very best contributor in 80% of the counties in which they occur is one of our oaks. We have 91 species of oaks in this country, 91 species of native oaks in this country. You do not need English oak. You do not need Chinese oak. 91 native species. And they're contributing more energy to local food webs than any other plant genus by far. A good example of a non-contributor would be a ginkgo, very popular ornamental plant, has good fall color, but nothing eats a ginkgo. So it's not adding any energy to local food webs. And a good example of a detractor, again, would be any of our invasive ornamentals like calorie pear or Bradford pear here. Burning bush, privet, you know what they are. Not only are they not supporting caterpillars, but they escape into our natural areas. And we already gave you the stats, reducing caterpillar populations by 96%. This is a land conservancy, by the way. They own the land, but it's not a functional ecosystem because of that one species of invasive plant. So plant choice matters. That's my point here. If I want to have the beautiful Pandora Sphinx at my house, I got to have Virginia creeper because that's its host plant. If I want the tulip tree silk moth, I need tulip tree. If I want the Luna moth, I need sweet gum. Now, Luna moth specializes on different things as you move around the country, but on the eastern shore of Maryland and up into the Piedmont, it is sweet gum. Zebra swallowtail, the only thing it eats anywhere is pawpaw. Native grapes are good host plants. The eight-spotted forester moth and many other species depend on them. The green marvel is on viburnum. Brown-hooded owlet on goldenrod. 110 species of caterpillars in this area are on goldenrod. It's one of our top plants for supporting caterpillars. Even poison ivy, the beautiful Utilia, is a poison ivy specialist. You know when you get poison ivy? When you try to get rid of it. Learn what it looks like and don't touch it. It will not chase you. And of course, we didn't talk about it, but the berries that poison ivy made, they're high in fat, very important berries for birds in the fall. Sculptured moth on persimmon, the Hebrew on black gum. Ashes are being devastated by the emerald ash borer, but they support a number of species of beautiful sphinx moths, like the fawn sphinx, rosy maple moth on maples. This is the royal walnut moth, one of my favorite moths. It's extirpated from New England already. So we are losing these wonderful species. Double-toothed prominent on elm. The witch hazel dagger moth, believe it or not, is on witch hazel. Imperial moth on pine. The spotted thyrus on clematis. The native clematis won't touch the non-native clematis. Shy cosmet on cattails. They're up in what we used to call punks. Got a beautiful moth in there. Two-toned ancillus on ironwood, the lost owlet on buttonbush, herald on native willows, snowberry clearwing on corals, honeysuckle, so some great coral honeysuckle today. That's our only native honeysuckle, by the way. That's the one you should have. Evening primrose moth on evening primrose. It spends the day with its head stuffed in the flowers. Sometimes it's crowded, but it's always very cute. The showy emerald on sumac, not poison sumac. I've never seen poison sumac. That's a plant of the swamp or something. I'm talking about staghorn sumac or smooth sumac, great soil stabilizing plants. And then you have some really powerful plants like native prunus, your beach plum, your black cherry, that are supporting caterpillars like this, the white furcula, the crocus geometer, the io moth, the cecropia moth, the colorful zale, the tufted bird dropping moth. Who wouldn't want the tufted bird dropping moth? The paddle caterpillar. Tell your kids to go out and find a paddle caterpillar, and ask them to figure out what those paddles are for. And don't tell them. Let them think about it. And I'm not going to tell you. I want you to think about it. It's the same reason that the filament geometer has these expandable filaments on its back. The small-eyed sphinx, these guys are all on black cherry. Harris's three-spot, it's got a little umbrella of its shed head capsules. Every molt, it sheds a head capsule, and this umbrella gets bigger. And if you get near it, it whacks you with it. The snowy-shouldered eclairus. Oaks, the most powerful plant, will support things like the hag moth that thinks it's a tarantula. The red-washed prominent, the white-dotted prominent, the spiny oak caterpillar, the skiff moth, the white-blotched heterocampa, the oak skeletonizer, the solitary oak leaf miner, orange-patched smoky wing, half-oval ancillus, the crown slug. These guys are called slug caterpillars because their head is tucked up underneath, not because they're really slugs. The pink-striped oakworm. This is my favorite, the spun-glass caterpillar. And hundreds more species are on our oaks. 557 species of caterpillars on oaks in the mid-Atlantic states. It is our most powerful plant. which is why I call oaks keystone plants. Remember, we're trying to support the food web. How are we going to feed those birds? You've got to have the plants that make the caterpillars, and oaks do it better than anything else. The keystone, remember, is the stone in the middle of the Roman arch. And if you take it out of the arch collapses. Well, if you take keystone plants out of your local food web, the food web collapses, because those are the plants supporting most of the food. Just 14% of our native plants are supporting 90% of those all-important caterpillars. So I like to think of keystone plants as if they are the 2x4s in the ecological house that we're building. They're the support structure. You can't build a house out of wallpaper. And that's what we've been trying to do for the last century. Again, 557 species in the mid-Atlantic states, over 950 species of caterpillars nationwide. No other plant genus comes close to that. This is where you find out what the best plants are where you live. You go to Native Plant Finder and the National Wildlife Federation website and put in your zip code, and the ranked list of the most important plant genera, woody plant genera and herbaceous plant genera in your county will pop up. And the lists are much bigger than that. I just ran out of room. But the old excuse, if I don't know what to plant, it's just an excuse now. You do know what to plant. So where did I take all those pictures I just showed you? I took them in my yard, and that's what my yard looked like. Our yard, my wife lives there too. When we moved in the year 2000, it was a piece of a farm. It was broken up into 10-acre lots. It had been farmed for over 300 years, so the soil was exhausted. Most of the topsoil was down in the holler over here. And it had been mowed for hay before we moved in. So really, blank slate. And the goal was to restore the eastern deciduous forest with a little bit of meadow there, which we have pretty much done. You always have to fight the invasives. But the question is, has life returned? Is it worth doing? Does this work, is what I'm trying to say. You can measure life any way you want. We measure it in terms of the number of breeding birds, the birds that have bred on our property, and the number of moth species that are creating the caterpillars that those birds use to feed their young. So we're up to, well, let's see, I'm still taking pictures of every moth species that I find. Not finished yet, but I'm up to 1,351 species of moths that have moved in because we put the plants back. Bottom line is, this works. It works. Nature's really resilient. Including Thaxter sallow. Got that this year. What's important about Thaxter sallow is it is on the brink of, it is a species of concern, but it is on the brink of being endangered. Yet it just showed up at our house. It's an oak feeder. We put the oaks back, and there it is. We planted all these plants, and we tolerated these plants. Most people think black cherry's a weed. Grapes, they pull them down off the trees. Tulip trees, they're okay. They're not high value. Virginia creeper, everybody hates Virginia creeper. They think goldenrod makes them sneeze. So even our poison ivy, our greenbrier, our dodder, they're all supporting important groups of moths. So in other words, you can recreate a functional ecosystem by increasing the plant diversity on your property. And when you do that, you create the caterpillars that allow the breeding birds to come into your yard. We now have wood thrush on that blank slate, forest breeding birds, because we've got the food that supports them. Everybody says wood thrush need tall, mature forests. What they really need is leaf litter, because they're thrushes, they forage on the ground. Although the oak trees, the acorns I planted in the year, actually it was 2001, those trees are now over 60 feet tall. So they really come back quickly. But we've got them because this particular moth, the leopard sphinx, comes from Virginia creeper, and we have a lot of that. We've got indigo bunnies because we've got alders making ruby quakers. We've got chipping sparrows because we've got black walnuts making great edged bomolokas. We've got field sparrows because we have oaks making red-lying panapoders. We've got titmice because we got black cherries making dowdy pinions. Phoebes because we have native grasses making skippers. Robins eat worms. Well, they do eat worms, but all you have is a lawn, and that's all that's there. But these are all the moths produced by the weeds that everybody wants to pull out. Carolina chickadees, of course, are eating lots of things, including the tulip tree beauty that we have because we have tulip trees. White-eyed vireos are eating the spicebush swallowtail that we have because we have spicebush and sassafras. They're closely related, believe it or not. House wren, because of hickories making copper underwing. Bluebirds, because we have sycamores making drab prominence. We have recorded 62 species of birds that have bred on our 10 acres. Not flew by, but bred. Why am I telling you this? Because this is another headline that we see all the time. The World Wildlife Fund says that 2/3 of Earth's wildlife have vanished since 1970. It's a terrible statistic, but I'm thinking, gee, not at our house. I am convinced we have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody put the plants back? We really could turn these terrible statistics around. So if you choose the right plants and use more of them, this could be your yard. We could restore insects and functional food webs and our bird populations everywhere, and our pollinators. So I'm going to leave you with 11 things you can do to restore the ecosystem in your yard, starting with reducing your lawn. We have 44 million acres of lawn. Now that statistic keeps going up, which is an area bigger than all of New England, dedicated to an ecological deadscape. Why do we do this? Well, it's a status symbol. It's a very important status symbol. We humans need our status symbols. We like neat. It's easy to maintain a lawn in a very neat way, and we have to display our Halloween decorations. You know, I drive by this church in Mississippi when I go down there to talk, and it strikes me. Everybody's inside worshiping God's creation, and on the outside they're killing them. With that giant lawn that supports nothing. We just don't think. We're not thinking. Plant for specialist bees, we talked about doing that. Remove the invasive species from your property. So these are major invasive species around here, but again, it's a big list as you move around the country. All you have to do is get rid of the invasives on your property. Public spaces, that's a different story, but remember, 78% of the country is privately owned, 85% east of the Mississippi. If everybody got rid of the invasives on their property, we'd be 85% done in the east. Not completely, but it's a real good first step. Where are most of your invasive species? They're on the edge of your property. What you call I don't know what, an edge. But I look at my neighbor's edges, it's nothing but invasives. It's their responsibility to remove that, and they just don't know that. Use keystone plants, we talked about that. Landscape for caterpillars. What do I mean by that? Not just choosing the right plants, but how we landscape under those trees becomes really important for caterpillar survival. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, develop on the tree itself. The caterpillar eats the leaves, then it spins a cocoon and hangs from one of the branches, then it emerges as an adult, then it does it all over again. Everything happens on the tree. But that is an exception. 94% of the caterpillars on oaks, and that's just an example, will drop from the tree after they finish growing, and they pupate underground, they wiggle their way underground, or they spin a cocoon in the leaf litter that's under the trees. And that's the problem. There is no leaf litter under the trees. We don't tolerate it, it's messy. And we mow and compact the area under the trees so that it's rock hard and makes it very difficult for those caterpillars to get to safety. And of course, the cement landscape is not the solution either. This is what most people have. They've got a tree in their yard. I just had a grad student, Emma Jonas, finish up, got her master's, measuring how caterpillars do in a situation like this versus a situation like this. And of course, they're doing better here. And the primary reason turns out to be, not that there's native plants here. You know, they're dropping out of the tree when they're ready to pupate. They're not eating anymore. Heather Holm calls this soft landing. And again, it's not really that it's a soft landing. It's that the soil is not compacted. When you walk under your tree, when you mow under your tree, you're compacting the soil. Most of these caterpillars pupate very close to the surface. Within a half inch, you walk on them, you squish them. So traffic under your tree is devastating to the populations of caterpillars up there. If you make beds under your trees, those are no-go zones. You're not walking in them, you're not mowing them, and that's why the caterpillars will do so much better. You can do your fancy spring ephemeral gardening under your trees that way. So we're not talking about, we're talking about more gardening here. We're talking about, and this is the way you reduce your lawn, by the way. Increase the size of the beds under your trees, and you've reduced your lawn. A lot of native ground covers. We talked about green mulch this afternoon. We're talking about plants. You don't even have to see the ground. You shouldn't see the ground, like wild ginger, May apples, foam flower ferns. The trees will love it, and so will your pupating caterpillars. Reduce light pollution. Light pollution is a major cause of insect declines, not just in the US, but around the world. Those are all the ways that lights are killing our nocturnal insects, particularly the moths that make the caterpillars that are so valuable to our food webs. And it's a really, really serious environmental problem, but it has a really, really simple solution, which is great because most of our environmental problems are tough to solve. This one's not. You can turn your light off. It's pretty easy. But I know you're worried about the bad man. Put a motion sensor on your light so it only turns on when the bad man comes. And that's not very often, believe it or not. And if you don't want to do that, take the white bulb out of your security light and put in a yellow bulb. Yellow wavelengths do not attract nocturnal insects. They sell them at the hardware store. You don't even have to get a new product here. It's called Bug Light. You can get incandescent, but there's a new study just came out showing that the yellow LEDs are even more effective. They're attracting even fewer insects. So if we were to switch out our white bulbs for yellow bulbs overnight, we would save millions of insects, and if we use LEDs, we'd save millions of dollars too. Oppose mosquito spraying. Booming business around the country, and I get it. You guys live on a salt marsh, and you make a lot of salt marsh mosquitoes. It's just a feature of where you live. This is a booming business all over the country, not just next to salt marshes. What's disturbing is the false advertising. They say it's a natural, organic product that only kills mosquitoes. Natural, it's pyrethroids, which are patterned after the compounds in chrysanthemums that kill insects. But it's industrial strength pyrethroids. And organic, yeah, it's a product made by a plant, but cyanide is a natural organic product. Ricin is a natural organic product. So being natural and organic is just misleading the public. And then they say it only kills mosquitoes. That's not even close to true. It kills all the insects, including our almost ought to be endangered monarch. We've lost more than 96% at this point. This was a result of a mosquito fogging event on Kent Island in the Chesapeake. My friend happened to be there and he picked up a handful of monarchs, but he said there were thousands on the ground because it was during a big migration event. It's killing the pollinators that we're trying to support. It's killing the caterpillars and all kinds of things that we're trying to feed our birds with. And it doesn't control mosquitoes. To control mosquitoes in the adult stage, you have to kill 90% of them. These guys kill about 40%, so they have to keep coming back and back and back, making sure your monarch is really, really dead. If you really want to, I have to be careful here. If you want to kill mosquito larvae at your house, mosquito dunks are the way to go. You get a bucket, you fill it full of water, you put in a handful of organic matter, straw or hay or dead leaves, and put it out in the sun for a few days. That builds up populations of diatoms and algae. And that is what mosquito larvae eat. Not all the species of mosquitoes, but the primary Culex mosquitoes that are biting us, they will come, the females will lay their eggs in your bucket because it's the best place for their larvae to develop. Then you go to the hardware store and you buy a sheet of mosquito dunks. Bacillus thuringiensis, which is a natural bacterium that only kills aquatic diptera. And the only aquatic diptera in your bucket is a mosquito larva. Some people out there saying, well, yes, your mosquitoes will lay their eggs in your bucket, but after they lay their eggs, they're going to want to bite you again, which is true. They want to lay more eggs, and to do that, they have to have a blood meal. And they say if you have a mosquito bucket in your yard, you're going to pull more mosquitoes in than you had to begin with. Nobody's measured that, and I'm not sure that's the case, but keep in mind, that's something to think about. Here's something that really works. Put a fan on your picnic table, turn it on, and sit in the directed breeze. Mosquitoes do not fly into wind, and then you don't have to kill anything. Okay, minimize insecticide use all together. If you go to the hardware store and you look at the shelves of home insecticides that are sprayed, the only insect that we need to control at home are termites. And there are specialists that do that, and they actually do it with termite baits. They use very little material. All the rest of the stuff is totally unnecessary. They're taking advantage of entomophobia. If you see an insect, you've got to kill it. No, you don't. Leave it alone. You get a jar, put it over the, it's called what do we call it? An insect removal kit, spider removal kit, that's what we call it. And put it outside. And bug zappers, by the way, way back in 1996, we did a study with bug zappers, put trays underneath them to see what they were really killing. And you get a lot of dead insects in there. When it explodes, yay, we just killed an insect. Well, it was 99.98% non-target insects that are killed by your bug zappers, not your biting flies. 0.02% biting flies. So almost everything you're killing with a bug zapper is part of the food web that you don't want to kill. So don't use a bug zapper. Share a native plant. You know, a lot of people have good native gardens and they have more plants than they can use. Every year they reproduce, put them in a pot and give it to somebody. The supply of native plants, the demand for native plants exceeds the supply right now. So you can help while nurseries are catching up. Nurseries are realizing that this is a business opportunity. It's not that they only want to sell Chinese plants. They just want to sell a plant. They want to make sure you're going to buy it. So this can help. And then finally, we have to address HOAs. A lot of people say, I can't do anything you say because my HOA says I'm not allowed to. Join your HOA, educate them from within. It's much better than suing them. But by the way, if you sue them, you're probably going to win now. There's actually a precedent for it. But join them, educate them. And I'm getting emails saying that actually works. You know, hey, they're people. They're listening to me. So HOAs are worried about reducing property values. If you landscape in a way that's socially acceptable, they don't know where the plant came from. They just want it to be socially acceptable. Then they don't worry about it. All right, we're going to end with E.O. Wilson, the way we started. 2016, he wrote Half Earth, Our Planet's Fight for Life. He's worried about conservation. How are we going to save life on planet Earth? Well, he says, in order to save life, we're going to have to save nature. We're going to have to save functioning ecosystems on at least half of the planet, or it will disappear everywhere. And that includes humans. Very bold statement. And he spent most of the book talking about the science that supports that very bold statement, and then he ended the book. He didn't tell us how we were going to save nature on half of planet Earth. How could we possibly do that? Remember, half the Earth is in agriculture. We've got 8.2 billion people in the other half, along with all of our hardscape and everything. Well, I think we can do it. I think we can do it. But to realize E.O. Wilson's dream, we need a new approach to conservation. We've got to give up the idea that humans and nature cannot coexist. We've had that idea forever. The only path forward is to be in the same place at the same time. We can do it, and I've just given you lots of examples. It doesn't mean you have to save insects, you have to save nature, you have to save birds for a living. But you can save them where you live. And if you do, it empowers you. Most people think about the entire planet. It's depressing. What can one person do? Well, one person can shrink the lawn. One person can remove their invasive species. One person can fire Mosquito Joe. One person can use keystone plants. One person can change their light bulb. One person can do all the things we just talked about. And then you're part of the solution. You're not part of the problem. And you get to see the results. It also shrinks the problem down to something that's manageable. You're not going to save the planet's problems, but you can save the planet's problems where you live, or any piece of the planet that you can manipulate. If you don't own property, help somebody who does. Help a park or preserve. They are all underfunded, they're all understaffed, they will love you as a volunteer. So insect decline is a global problem, but it does have a grassroots solution. We created this problem, we can solve it, and I'm going to end by telling you a little bit about Homegrown National Park. This is one organization you can join. It's small nonprofit, homegrownnationalpark.org, and all you're going to do is go to our site and register your property on the biodiversity map. What that means is you're putting down your location and the amount of your property you're going to be a good steward of. You're going to help create a park. Maybe you really are going to reduce your lawn. Maybe you're going to plant that oak tree. Maybe you're going to change that light bulb. And then your little piece of your county is going to light up with a firefly. That's our little emblem here. And of course, we want to get the entire country to light up with fireflies. Our mission is very simple. We want to motivate millions of people to regenerate biodiversity in the way you regenerate biodiversity. And that's by planting native plants, removing the non-natives that don't support it. And we want to build a culture that's sympathetic to the needs of conservation. There are real ecological products associated with homegrown national park. One is a significant increase in biodiversity. And what's happened at our house just tells me this works. Measurable reduction in invasive species, particularly if everybody gets rid of them on their properties. Lawn is the worst plant for sequestering carbon. So if we reduce the area of lawn, we're going to sequester more carbon dioxide. And we're going to create viable habitat outside of parks and preserves. Every bit of conservation we do outside of a park is going to help conservation inside of the park. Equally important, though, are sociological products associated with homegrown national park. And one of those is national awareness, not just of what the problems are, but what the solutions are and what our roles in those solutions are. We really do want to change the culture. We want people to recognize that nature's not optional. It's not just there for our entertainment. It's essential. It's essential for everybody, which means everybody owns responsibility to sustaining it. We want to convert hope into action. Hope is good, but action's even better. And we want to merge all the existing conservation organizations onto one visual, the biodiversity map. There's wonderful conservation happening at Audubon, National Wildlife Federation, Wild Ones, all the land conservancies, but nobody's measuring it in one place. We want to see how we're doing where the gaps are. We've got Canada playing this game now. We're talking to England. It's really a global issue. So Robert Swan. Oh, did I mention that it's free? It's free. We're not trying to pull membership away from any other organization, which is why we don't charge. We just want to record good conservation on private property. Robert Swan recently said the greatest threat to our planet is believing that someone else will save it. It's not going to be someone else, folks. It's going to be you folks. How we act today is going to determine what nature's fate is, and then ultimately our own. So those are the websites that I talked about, and I'm happy to answer any questions if you have them. Thanks very much. Yes.
It's funny, as you mentioned fireflies, I had just had that thought. What is their significance other than just being amazing to look at?
What are fireflies? The significance of fireflies. As larvae, they are predators in leaf litter. If you rake your leaf litter away, you throw your fireflies away. So it's another reason to keep leaves on your property. But they're predators. You know, insects reproduce really quickly. If we had nothing eating them, and most of the things eating insects are other insects, then things get out of hand. So, yes, way in the back.
Yeah, I was curious, sorry, just stand up. I'm in the process of building a company that does data analytics. And I've been finding that the most resistance has to do with ticks, specifically in our environment. And I saw on the Homegrown National website a study that was done by Yale about the biodiversity of flora or fauna and how it affects the microbiome of the soil.
All right.
And how it abates Lyme disease. Are you familiar with that?
Do I agree with it?
Oh my gosh, it's on Homegrown National Park.
Yeah. You know, I'm missing the question part of your question.
I guess I was wondering if you had some information to share with everybody, because it seems to be the largest resistance towards installing native tall grass netting.
Well, there are more species that live underground than above the ground. That's one piece of information. They all require high humidity, which is why we want to keep a layer of leaves on the ground. So yeah, it's an extremely diverse, essential part of our ecosystems that goes underappreciated because we don't see it. But the mycorrhizal fungi that transfer nutrients from the soil to our plant roots are down there. If they dry out, they're not down there anymore. We've got to get the nutrients back into the soil. That comes from the leaves that fall from our trees every year. Most of the things living in the soil are detritivores. They're breaking down that leaf litter. So when you have a lawn and you put your lawn care industry on, all the stuff on there, you're destroying that soil biome. And it's just another reason we don't want to do that. Yes?
So leave the leaves alone.
Leave the leaves alone. You know, my son bought a house a couple of years ago, and the first fall he called me up and he said, "Dad, I got too many leaves. What should I do with my leaves?" I said, "Put them in your flower beds." He said, "I don't have enough flower beds." I said, "Exactly." That's how you shrink the lawn. Now, I know you want to remove the leaves from your lawn, but you're going to have less lawn. Our plants are much better at getting through those leaves than we think they are. We think if there's any leaf on your flower bed, it's going to smother everything. Who was raking the leaves before we got here? And there were plants in North America. I read about it. So, yes. Two of you. I'll get both of you.
My question was, I'm not sure you've heard them, but I'll speak for myself. I am concerned, and I use, I will say it, pesticides because of deer ticks. And deer ticks here are spooky bad.
They're spooky bad everywhere. Are those pesticides controlling your deer ticks?
You know, in a way, I don't know. In another way, I think they might be. I don't have enough information.
What pesticides are you using?
It's that organic shit that everybody. Like the company, and they say it's organic, it's product.
Yeah.
So,
No, yeah, I get it. I've had Lyme disease 5 times. We have deer ticks all over our property. Why? Because we've got too many deer. It's the whole Lyme disease issue has come with the explosion of deer, and the only way to actually get rid of Lyme disease is to control our deer. Poisoning the entire environment so that we have no more ticks is just not the solution, because then you're killing everything. There are a few products that do seem to help. One is called Daminex and its derivatives. So it's essentially cotton balls that are soaked in pyrethroids, and the tick tubes, right? The mice that are small rodents, but particularly white-footed mice that are a vital part of the deer tick, the Lyme disease cycle. Take those cotton balls back to the nest, build their nest out of it, and it kills the ticks that are on their body. There's pretty good evidence that does reduce ticks. But yeah, I understand. It's just not the ultimate solution. The ultimate solution, for a number of reasons, is to reduce the deer population. Now, you had a right in front, yeah.
You comment about, shredded dyed mulch is very popular with the green lawn, especially the black. Could you comment on shredded dyed mulch and its impact on insects, ground dwellers, etc.?
Oh, I don't think anybody's actually studied its impact on soil insects. But we're very funny. We rake away the leaves, the best mulch, and then we go out and we buy terrible mulch. Especially dyed mulch. I mean, red mulch. Our landscapes are more than decorations. That's all I can say. You don't have to buy anything if you keep the leaves on your property. So, yes.
I just want to confirm what I'm hearing. You're saying no raking, no leaf blowing, none of those things?
No, I didn't say that. I said you want to keep all the leaves that fall on your property. I know you want to move them around some. Some of the lawn, you do want to keep lawn where you're going to walk. It's the best plant to walk on. It's a cue for care, showing that you get what the current culture is. And the lawn you keep is going to be mowed and manicured so that nobody throws you out of your neighborhood. You're just going to have less of it. So you want to get the leaves off the lawn. Raking them as they fall is probably a good alternative. You can leaf blow them, and then everybody hates you for the noise you just made. Shredding them just shreds the Luna moth and everything else that's a pupa in those leaves. But putting them, I say, move them into your flower beds, and if you have too many leaves, for sure, like my son, make a compost heap and just store them in there, and then at least you're recycling the nutrients.
I have a ton of ivy on my property, and I don't know if it does any good. I mean, it is like a green mulch, but can you comment on ivy? You're just
English ivy.
I guess. I don't know.
Yeah. Well, yeah. So as a food web supplement, it adds nothing. Nothing eats ivy. It's invasive. It spreads. All of Oregon is covered with ivy. It is banned for sale now that it's decades too late to ban it. Now it's banned for sale. So it's a highly invasive species. If you can get rid of it, you want to. It is covering the ground, so it does, help the soil community in that sense. So it's not that every plant is all bad in all ways, but you could replace it with Virginia creeper, with there is a native pachysandra, by the way. Lots of other things that actually contribute to the food web that are not invasive. That's what you want to do. Yes.
So, getting back to the question about ticks, I'm just wondering, have there been any studies that have compared tick densities? I'm thinking by species like Lone Star, which tend to prefer more open areas versus deer ticks, comparing, rewilded landscapes with more conventional landscapes.
Well, the websites will tell you ticks don't like mowed lawn, and that is correct. They want vegetation that they can crawl up on, put their little legs out, and it's called questing, and they want to grab onto you. So they say, make sure you have a big lawn so that you don't have ticks. Paving it over, you'll even have fewer ticks at that point. So we have to find some kind of ecological compromise here. I don't know of any studies comparing the frequency of Lone Star tick versus dog tick versus black-legged tick. All these ticks like high humidity. So in a spring like this, where we've had a lot of rain, they love it. It's not that they love brush piles or anything else. They like areas of high humidity. So I don't know. Did I answer your question? Yes.
One suggestion that I read about that was so you don't have the shrubbery and plants by your lawn, just use those extra leaves to widen the mulch, the leaf mulch around the higher shrubs.
May and June are the peak months of transmission. It's a good time to stick to your paths, to stick to your lawn. I am lucky because when I get a deer tick, it itches, and it itches really fast. So in the last 2 days, I have removed 3 deer ticks. So they're there. Am I going to stay out of my yard? No, but that's my personal decision. This is called risk management. You can stick to your yard during the areas of peak infectivity, but ultimately we want to get the deer populations down. Yes? Now, birds and spiders are not going to control deer ticks. They are minute, particularly those little larvae. They're like a period. You have a lot of deer ticks to make one mouthful. So don't count on that. What does reduce the percentage of infectivity is having a diverse landscape with lots of mammals in it. So if you increase the population of alternative hosts, then they're biting those guys and not you, and it reduces the level of infectivity. And many of those mammals are dead-end hosts. The South is a great example. There are a lot of deer, and there's a lot of deer ticks, but there's very little Lyme disease. Why is that? Because they've got lizards, they've got skinks, and they've got anoles. And those are both dead-end hosts. And the ticks bite those lizards, and it funnels off the Borrelia, the disease organism. So this is research that comes from the Carey Institute in New York. Increasing the mammal diversity on your property will help to protect you. Yes?
We have an organic farm, and since we put up our deer fence, we don't have a tick issue. And so we don't spray, obviously, being organic. But I think it is unrealistic to ask a homeowner that has such a high deer population to not spray. And so when people ask me, even though I've dedicated my life to pollinators, I bring up the concept of zoning, and Long Islanders love zoning. So areas where you are congregating mostly, I don't see it being, I know the data, but I don't see it being that bad, because at least people are interacting with nature and being outside, and there's such a high incidence of tick-borne disease. So with your organization, do you kind of visit the concept of zoning so at least people do create buffer areas where they're not doing anything, and then they can still go outside and meet creatures and interact?
I want them to still see creatures.
Yeah, but it's just everybody gets sick out here.
Yeah.
Multiple tick diseases.
You know what I really want? I want the public to stop opposing deer control. That's what I really want.
I agree with you, but there's still so many deer.
Yeah. Yes.
What's your opinion on dead hedges as far as increasing insects?
Deadheading?
Dead hedges, where you take, instead of having your sticks pulled away by the town every spring, you pile
Oh.
into edges.
And what's that supposed to do? Wildlife likes it.
It would increase the insects, I think it would be beneficial, because instead of taking away even the sticks, just like not taking away the leaves, not to take away the sticks as well.
Well, it keeps organic material on your property. Insects don't, well, I wouldn't say that. What do I think about it? We got a lot of stick piles on our property. We don't take anything away. Yeah. Somebody had their hand up over here? Yes.
Back to the ticks. I would say that we talked to risk. I've had lions 3 times. I don't stay out of my garden and I don't spray. But I do, my husband bought me a hazmat suit. And those little throwaway things so that when I go into areas where I need to take care of invasives, I've done. I have my clothes sprayed with pyrethrum. I put my pants inside my socks. I have, as you say, areas that are pathways that you can go on when you don't take all those protections. It's if you spray selectively, there's drift. It's not going to stay in a select spot, right? It's going to drift all over. So I think that it's our responsibility to take care of ourselves and not destroy other things instead of that.
On the back.
Thank you so much for this talk and all the work you're doing. It's really incredible. I wanted to see if you could just talk very specifically about leaf blowers. I know Southhold is now starting a petition against leaf blowers. I know other towns in Long Island have done that. Besides it being a nuisance, which we all know it is, has there been any studies that showed like the power of the air affecting wildlife? I can't imagine, especially insect life, can't imagine that it doesn't, but you don't really specifically talk about it and it's so prevalent.
Yeah. I don't know of any studies, but it's really not my area of expertise. There might be. What we certainly don't want to do, I've seen guys going into the woods and blowing it bare, just blowing everything out. And that definitely hurts everything that's in that leaf litter. But leaves that just fell that year and they're on the ground for 2 days and you blow them away, it probably doesn't hurt anything. So it depends on the context. But I don't think it's been studied. Yeah.
Wouldn't the sound of the leaf blower harm insects?
Again, I don't think anybody's studied that, but we are a noisy species, and there are lots of studies looking at the impact on birds, particularly bird communication, traffic noise, leaf blowers, all of that. They're birds that are actually changing when they sing and how they sing so they can talk to each other. So noise is an impact. There's studies, you can see it on YouTube. You can kill a mouse with a loud noise. It spins around and finally just dies. So noise it ups your stress hormone, and if it's not necessary, we shouldn't make it. Yes?
I know this might not be, I'm curious about spiders and their value, because we have so many spiders.
Spiders.
Yeah.
Spiders are predators. They're eating the mosquitoes that we hire Mosquito Joe to kill. They're extremely valuable predators. They're highly diverse. They're spiders, in all layers of our all the niches that are out there. So yeah, high value. Yeah.
Could you comment how one finds caterpillars on our native plants?
How do we find caterpillars? Yeah, the caterpillars don't want to be found because the birds are really good at finding them. So they're hiding from you. Many of them are highly cryptic. They look like leaf edges. They look like damaged leaves. They look like algae. They look like fungus. They crawl off the leaf during the day and are hiding on stems or the trunk or sometimes in the ground. So the birds aren't going to find them there. The best time to find caterpillars is at night. You go out with a flashlight and you look at, because the birds are not hunting them then, and then they go out and then they do most of their eating at night. During the day, the caterpillars, if they're out in the vegetation, they're underneath the leaf. They're never on the top unless they taste bad. If they taste bad, they are on the top to advertise that. I showed you a lot of pictures of caterpillars. I didn't find all those on one day, So you have to, and you develop what we call a search image. You use your knowledge of what the caterpillar is eating. If I want to find monarch caterpillars, I'm not going to look on an oak tree. I know it's only going to be on milkweed. And you can do that with most of the species that are out there. You know what its host plant is, and that's where you look. But you have to be, you have to say, this is what I'm going. If you say, I'm going to go look for one of the underwing caterpillars, you won't find it, but you'll find something else when you're looking. So, but have something in mind when you're looking. Yes.
Could you just say a couple words about the equipment you use for all those people?
The equipment I use, everything's digital now. It's a Nikon, but it's not the camera. The Canons and everything else is just as good. Lenses, it's a macro lens for the caterpillars and different telephoto lenses for the birds. The key to good photography in the digital age is to delete your bad ones. And then you only have good ones left, and that's how easy it is. In the old days, it was 25 cents a shot, and you didn't know whether you got it or not until a week later. Now you can look right away, oh, that worked, it didn't work, and you keep shooting until you get what you want. So digital has really changed how easy it is to be a good photographer. Yes?
Do you take the moth pictures at night? Is that?
Yeah, you have a flash. So macro photography is a couple things. You have to have a big depth of field. Otherwise, only the front part of the insect is in focus. To have a big depth of field, you have to use a low f-stop, f16 or lower. That'll give you the depth of field, but that blocks light. So the only way to get enough light is to have a flash. Even during the day with small insects, you have to have a flash. Yes?
Yes, I just want to make sure that I heard you right. The organic quote-unquote spray from chrysanthemums, it does kill all insects, including monarchs. That's what I heard.
Yes, that is correct. But you know what? Most of the evidence, like that picture of the dead monarchs, they're pretty dead. It's anecdotal. But this summer, we are doing, in my lab, we're doing a controlled study, highly controlled in lots of different ways, looking at the impact of mosquito fog on non-targets. So at the end of the summer, I'll be able to give you real numbers, not just a bunch of pictures of dead insects. This is pyrethroids are a general insecticide. There's no way it can kill one type of insect without killing the other types of insects at the same time. Yes?
How do you know which insects are eating your plants?
You catch them in the act is the best way. A lot of the damage you see on your leaves, particularly your woody plants, is again happening at night. A lot of it happens from beetles. We've got 3, 4, 5 species of Asiatic beetles we have introduced. So they're related to the Japanese beetle, but they're out at night and they're munching away on your leaves. A lot of Asiatic weevils are doing the same thing. But some of our native scarabs, they're out there, June beetles, they're up on those leaves eating them. You never see them during the day, but they're at it at night. But yeah, you don't really know. If you just see the damage, you have to catch it in the act. Yeah. One more. Yes, that's you.
How about neem oil? Is neem oil okay to use on roses or for little?
Neem oil comes from the neem tree in India, and it has mild insecticide properties. So it's another form of killing insects.
But if there's a particular insect eating your roses, a little leafhopper on your rudbeckia, and you're killing everything. It's still...
Most of the insects eating our plants are not killing everything. We tend to think if it's on the plant, it's going to kill it. That's typically not true. Sometimes we get out of whack. Often when we try to control things like aphids, we'll spray them, whatever. You don't control the aphid, it comes right back. But what you did do was eliminate all the aphid parasitoids and the predators. So then you're on the insecticides treadmill. You've eliminated the natural enemies that keep these things under control. What we have to do is tolerate some pests in the beginning so the natural enemies come. And we tend to overreact. We see something on a plant, got to spray it right away, and then you're spraying the rest of the season. All right, one more.
Have invasive insects, how have they affected our native insects?
Our native insects. Invasive insects have certainly affected our native plants, like the emerald ash borer, gypsy moth, which is now the spongy moth.
But are they eating are they consuming their
food? Yeah, and our reaction to things like the spongy moth. What do? We fly over the forest and spray 7 or some other thing. It does kill the spongy moth, but it kills all the Lepidoptera, and then the birds have nothing to eat. So that's the biggest impact.
On behalf of the North Fork Audubon Society, we thank you so much, Dr. Tallamy, for this fantastic, educational, enlightening, and very well said conversation with us.
Except for that tick stuff. Don't ask me tick stuff.
No more tick stuff. About how what we can do our part in our neighborhood. So thank you all for supporting this and for